streaming. Etienne, did you lose your note package?
I wasn't here last.
But we got it the time before that, didn't we? Was last day the first day?
And as in,
It might have been.
No, we had 2 days working on
Okay.
I've been gone for a while.
I thought you were here one of them, but I could easily be wrong. Yeah, I'm going to propose that to admin. Fourth block on Friday. Have you seen the famous bullet hole diagram from World War II for our armoring planes?
oh, survivor bias?
Yeah.
Yeah.
Yeah, survivorship bias. Where's the picture? There it is. Beautiful picture. If your planes were coming back from World War II, and this is what they looked like, where would you armor?
There's no holes.
No, don't give it away. You already know about it. Engineers are like, we should put the armor plating here because that's where they're getting hit. Until a statistician pointed out, no, you should put it where the bullets aren't because those are the planes that didn't make it. So on Friday, we shouldn't cancel a class. We should add an extra one.
I
Sorry,
don't know.
did you need me?
No, I just want to, yeah.
My idea for Friday is don't cancel last block. Just add an extra class that is the buffer class that everybody will not pay attention to.
Exactly.
Yeah.
What about the rowers?
What about the rowers? They leave early anyway, no matter what. Rowers do what they want. Same with the entre students.
Sorry. Yeah, I'm going. I'm gonna. Are you in any commodity?
No, they scrapped our it's food in they scrapped our block.
I think I should know.
Oh, the other document's not opening.
At least you will show.
Do I need it? No.
I won't be in class
I
tomorrow.
can show every day.
Okay.
So morning rows.
Nothing here about that.
How long are you going to be gone?
So long.
Until 9
2
o'clock.
years.
Till 9 o'clock. Yeah. I do tell, and we do it, what was it in the science? Gravitational force and how it gets weaker by the square rather than linearly as it's different. And then I tell them to watch the grade 12s as all the couples start making plans to go to different universities and watch them slowly break up for the next month. You're welcome to that thought. Though, that being said, Will Pickles, and was it Will Pickles? No. Julia Allard of Allard House and Johnston, dated since he was in grade 9, went to separate schools, and then still got married and had kids. It was lovely. The funny part is I remember telling him how to survive dating Julia. Okay. Go. Does everybody have this down from last day? Now you do? Now you do? Gleb, you good? Good. Why is your laptop
I'm playing Strand.
open? Close it, put it in your bag. Strong acid, strong base, makes a water. Water ideally is what pH? 7. So this is neutral. And then what pH will that be? Another way of asking it is one, both, or neither of these ions spectator ions?
They're all both.
Both. All metals +1 and +2 are spectator ions. And all this is actually slightly wrong. Because now we've introduced this enough. All of these are spectator ions, the conjugates of the strong acids, because they can't react and go backwards. However, Why did I erase that one? Why is that not a spectator ion?
Because it can react on that side.
Yeah, you'll find it again down here. So it can do one more step. As a weak acid, not a strong acid, but still we can't regard it completely as a spectator. It will still do something, it just can't be a base. So, let's go all the way back.
Yeah, can you go back that other page?
Yeah, no, that's where we go.
Yeah.
So have your book out, those ions in front of you.
So wait, how did you know that KCl was spectator?
So, K, +1 metal.
Was it non-metal or metal?
No, it's a +1 metal.
Oh, okay.
So the +1 and +2 metals are all spectators.
Oh,
And Cl comes from HCl. So this is a neutral salt. It is the product of a strong acid and a strong base, and it won't do anything. Next. Put your computer away. Or are you writing notes? No, put it in your bag. You're not writing notes in that. Next one. Water, neutral. NaF. One, both, or neither are those spectator ions.
Both.
Both. Na is Na spectator. In fact, I'm not going to write spectator every time. That takes too long. I'm going to do this.
Unless you.
So that's a specter.
Just the NA?
Just the well, we determined the Na. What about the F?
It's just a skull.
That was good. That was subtle. Came in right with Etienne.
I know.
What about F? Spectator? Not a spectator. Spectator. What strong acid is it from? Everybody, look. Is everybody looking at their data booklet?
Yeah, hydrochloric.
Hydrofluoric is a strong acid.
yeah, pretty strong. Isn't it?
Oh, it can go back, so it's not.
It's not strong. Hydrofluoric is here,
That's like decently strong.
but it's not a strong acid. A strong acid is one that goes 100%. If you're 99%, you're weak.
So it's not a spectator ion.
So it's not a spectator ion. Because it can its conjugate react? Yeah, it's got a two-way arrow. It can do something. So that one turns out to be a weak base. So if we have a weak acid, we make a weak base. So what will be, if these react perfectly, you have just the right amount, will this solution be acidic, basic, or neutral? Basic. This solution will be a basic solution. If you have a weak acid that reacts with a strong base, it makes a basic solution. It doesn't make it because there's a strong base. It makes it because the weak acid has a conjugate that can also react. Question, Josh?
Nah, he's just showing me.
Okay.
I don't know. Could you
Do
scroll?
you scroll up for a second? There?
Yeah. Is the whole thing neutral then?
Yeah, the first one? Yeah. So if you have a strong acid and a strong base, your solution will be neutral. Most of the time.
What does that say from HCl?
Then it's HCl from HCl. I think it kept drawing after my pen. Here?
In a circle. You circled it? What's that say?
HF?
Oh, damn, I didn't see that. Well, that wasn't connecting. I thought that was like a 1 plus.
This was the thing.
Mm-hmm.
If the second product on the second equation wasn't water, would it still be basic? Or does it just depend on what that is?
If you have an acid and a base in which OH is involved, you'll always have water. If you have something other than H2O, it is possible for it to be acidic or basic because it could be something else. So if it wasn't water, could it be something else? Yes. But for this reaction, can you have a strong base that's not hydroxide? Pretty much no. For this, it's always going to have water. I always have to say pretty much because there's like always 1 or 2 cases in which but you're not going to have to worry about those. Next one, we have a strong acid, hydrogen iodide, and a weak base, sodium fluoride. Will this be an acidic or basic solution? We have a strong acid with a weak base. Acidic. Why?
Because it is unspectacular, is it? Acid.
Sorry, say that again?
Na is a spectator.
Yep. What about I?
Is acidic.
This one's acidic?
Well, it's oh,
Pretty sure that one's the spectator ion 2. If we go all the way down to here, you're guessing correctly, but iodine's right there. That's a spectator. Sodium's a +1 metal. That's a spectator. But there is one staring you right in the face. If you have a weak base, what is, of these two things, what's making it acidic? Where,
Another week.
a weak acid.
a weak acid. What's the weak acid in here?
HF.
HF. From the weak base, you made a weak acid. So you made the conjugate. So HF is just sitting there and now can react and make the solution acidic. 4 items couldn't be synced. Okay, go away. No, I don't. Down. Thank you. Maybe some practice on that. Am I still getting this down? Okay. Here's a question on the next page then. Which of the following net ionic equations describes the hydrolysis of KCN? I'm going to quickly do attendance and then I'll ask them on random. We'll go over the net rules. Good luck. Although you're not playing, so happy practicing.
Well, I think we are playing basketball.
No, no, tournament.
Yeah, no.
Oh, is it just practice or?
Where's he going?
Oh, it is tournament. Good luck.
Where's he going?
You're only excused if you win.
No, where's he going?
He just arranged. He can leave early sometimes.
If I can arrange that,
No, no, he's got. He met the bribe quota. So
you meant the what?
bribe quota.
I'm quota?
Yeah. Andrew,
I'm
Ashley,
gonna just be succinct anyway.
Ella. Pardon?
I'm gonna throw it, but I'm gonna go.
Ella's not here. Etienne, Gleb, Josh, Katie, Ravina, Max, Nathan just left. Neha. Nicholas. Was Neha here last class? Is she like away?
I think she's here.
She's not here, right? Nicholas, Sam, Sonia, Taz, Theo.
Say Sam's supposed to be here.
I saw them in the whole thing. She's in Cleveland.
Oh, damn it, Sam.
Is it what?
I saw her just once. It's fine.
He's doing a test.
You still writing the test?
Association equation. That's my process.
Okay, Josh.
Uh,
Which one of these is the net ionic equation?
One second.
Pardon?
I need a sec.
Okay. Net ionic. No spectator ions.
C.
Nice. I am going to go through the other ones though.
Wait, is it actually C?
It's actually C. When in doubt, pick C. Why wouldn't it be C?
Because it's correct. There's no KCN as a C.
Right.
Because you can
But-
OH minus.
Sorry?
OH minus.
You make OH minus, yep, from a weak base. What is K? K plus. It's a spectator. Do you include spectators in net ionic equations?
No.
Nope. So this can't be it because it has potassium, which is a spectator. This can't be it because it has potassium as a spectator.
It's not separated yet.
That's what I'm talking about.
The
For the
KCN.
spectrum answer.
What's not separated yet?
The K from the CN.
But they asked for the net ionic equation. That means you have to separate it. They didn't ask for the complete ionic. They asked for the net. Also, when they asked for the net, you don't separate weak acids. So that doesn't get separated because it doesn't completely separate. You only separate those things that are 100% separate. So complete 100% soluble, or like strong acids or strong bases.
Wait, so is KCN going with
Why is this one wrong? There's no K in that one.
Because it's just not.
It's just weird. I don't know what that is or how they got it. They just decided to move the oxygen instead of the hydrogen. So these have a spectator ion, and that's why they're wrong. And this one's wrong because it's weird. It's not even an acid base, really. It's just strange. Okay.
Can you go back?
Practice, just practice.
Love it.
Okay, what ions do not react with water? What are the spectators? I wrote them on the previous page. We've been eliminating them from equations. What ions are the spectators?
The ones that have a positive charge
Plus one. So, give me some of them.
Potassium.
Potassium. Keep going. Andrew, give me another one. Sodium, sure. Sodium plus one. Gleb,
Lithium.
lithium. Josh. Let's get them all. I'll just go around the whole class.
Plus one, or can it be also plus two?
Ooh, good question. Josh could give us an example and then we can see.
I don't have that.
What? You don't?
Anything in the left column.
Yeah.
Cesium, sure. Is cesium plus one? Oh, cesium is plus one. Okay. Francium would be fantastic. I'll just get that one out of the way. Because it's also radioactive and extremely expensive and you won't come across it. But it's cool to use when you can. Nick?
So can it be a plus two?
I don't know, try. I'll tell you if you're wrong. Pardon?
CU.
CU,
2 plus.
2 plus. I think, actually, technically you're right. It's not an example I was expecting, which is even better.
Calcium.
Calcium plus 2. Excellent. Sonia?
Copper one.
Also one I wasn't expecting. At this point, I'm sorry, Ashley. I'm going to say now you must only give me negative examples. Pardon? Iodide. Only negative examples.
Nitrogen.
Close. There is a nitrogen containing one. Do you have a table right beside you on the acid base page?
Yes.
Look where I minus is on the acid base table. Way up in the upper right.
Yeah.
And then pick one from there.
Oh, BR. Minus.
Cl minus.
Cl minus,
NO3.
NO3 minus, and Levina. Welcome back. You can look at this and now pick anything. I won't say you have to pick negative or positive. Excellent. That's perfect. Because that's going to lead to the next table, because that's the one that's not. So aluminum plus 3 metals are in fact acidic. Not neutral. Is in fact acidic. If you look down below, conjugate bases of strong conjugate bases of strong acid. Chlorine, chlorate, iodine, bromine, nitrate. It was mostly down there. Also,
I have no idea.
the conjugate bases of strong acids and bases. And this tends to be metals plus 1 and metals plus 2, because you can have calcium hydroxide, you can have copper hydroxide, you can have all these strong bases with plus 1 and plus 2 metals. Sodium hydroxide. So all of the metals plus 1 and plus 2 you can regard as being spectator ions.
And those are all ones that don't react.
Those are all the ones that don't react. Now, I'm a little hesitant because when we said copper, I also have to go back and look, is it actually soluble? You do have to then apply your solubility rules. I'm not going to pull up the solubility table and quickly whip through that. But just so you're aware, you should. This is essentially mostly alkali and alkaline earth in most cases. However, the conjugate bases of strong acids, there is one exception in there, something that does react. And Gleb's not allowed to say anything because he's already identified it once.
What?
Yep, just head down, don't look. So, which one of these does react? Which one of these is not like the others? No, I know you know. You're not guessing. Yes?
HSO.
HSO4? Because HSO4 can actually be an acid. It can't be a base, so put a big cross through this part.
Wait, but it is a conjugate base, right?
It is a conjugate base of a strong acid, but it's the exception because it can react as an acid. So it can't be a spectator ion because it will react. It just reacts as an acid, not a base. Maybe you didn't know. Pardon? NO3 what? I didn't ask a question, now you're just telling me ions. NO3 would have been one that you could have said before yes. Were you still answering that question?
Just
So of the conjugate bases of strong acids, these are all spectators. But HSO4 is not. Because it can react one more time.
What about like NH3?
Pardon?
What about like NH3?
What about NH3? Like, why are you asking about NH3? What strikes you about it like it should belong on pure? Are you saying it's a spectator?
Yeah.
Why are you
Oh
saying?
no, I'm saying it's not.
Oh, it's not a conjugate base of a strong acid.
The arrow only points to that, so it's the one.
Oh, you're looking at conjugate acids of strong bases. I didn't put that there for that. And the reason I didn't put that there for them, let's go over them, is that absolutely this cannot act as an acid. But it is a base. Where is it on here?
Missed it.
Did I? Did I go past it? Where is it? There it is. So much like HSO4, it will react. It reacts as a base. And I can't recall the last time we actually used that base. This end of the table hardly ever gets used. Sometimes there's oxides around, and you do need to know that it will react as a base. O-, O2-, I mean. But most of them tend to be stronger weak bases of the hydroxide type. Oops. Go back to there. Also, I told everybody you'd have a quiz in tutorial on Friday. There's no tutorial on Friday.
Hell yeah.
So the quiz will occur only in virtual space here. At some point during the day, just pretend you're having.
Why don't you just give us the questions now so we can just like crack them off?
You have all the questions. They're on the old exams. You just do them.
Wait, where are they?
On the old exams. Yeah.
This is mine.
No.
What? How?
What quizzes?
I just haven't done them.
You're ready to get in.
I was going to have them ready, and then when I saw that you didn't have tutorial, I slunk so low to a fit of depression. I ate ice cream and just didn't mark it. No, I just ran out of time, and since we don't have a quiz, it just slipped lower on my to-do list. Although I was also toying with the idea of taking your Hebden zone before the regatta. And then I realized if I announced that today, that would probably send some of you into panic before the regatta. Not Theo though. He's shaking his head, so no panic there. I'll take him Theo's. But a heads up, I will be doing that soon. Even if we haven't had a test, I want to see where you're at and make sure you're not falling too far behind. So if you haven't been keeping up, please, I will be on Tuesdays and Thursdays. Some have been coming regularly. It's been nice. Which of the conjugate bases of strong acids does react with water? We just did that. Why did I ask it twice? Why do I have this? I literally just answered it. It's that one. Save this for a work page. We're going to come back to this. Okay. Alkali metals +1. Let's go with light blue. Alkaline earth metals +2. These are neutral, and they're spectator ions. And these are considered the conjugates of strong bases. NaOH, CaOH, 2, etc. Metals plus 3 turns out to be an exception. You would think if you had something like gallium hydroxide or nickel hydroxide, and you had 3 of them, it would act like a strong base, and if it's soluble, it would. But metals plus 3, at a plus 3 charge, they are just so darn attractive. They start doing things in the water. And we're going to diagram it. Can I scroll down? Okay. Why is your laptop? Put it away. That's far too tempting. Lavina, you good?
Yeah.
Okay. Metals plus 3. Let's use chromium as an example. That's probably, we'll see chromium a lot more when we do redox. Chromium is a wonderful example. And I'm going to need water. Haha. Draw that. No, what do you do? Delete that one. I forgot I still had that in there. So chromium, from grade 11, do you remember the hydration spheres? When ions would dissolve in solution, they'd get a jacket of water molecules around them, and then around that jacket, they would look a lot like this. What is the slight charge on oxygen in water? Negative. Slightly negative, hydrogen slightly positive. The oxygen would rotate around, and you get another jacket around this. All ions have this. It's a jacket, it carries around, it's called the hydration sphere, carries around the ions, and that's why they're dissolved. Their attraction to the water is higher than their attraction to each other. Chromium's attraction is really strong at plus 3. It's stronger than all the other ones. And it's so strong that it will cut one of those off. In fact, it'll attract the electrons so hard that one of the hydrogens will pop off. So you end up getting, and I'm gonna do the shortened version, and then we'll write out, but without all the diagrams. And I'll actually draw it for the next one. So we've got chromium plus 3. I need 6 oxygens. 1, 2, 3, 4, 5, 6. I need my hydrogens hooking away. That's the one I cut off. So we have H, 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 H. So not too hard to draw. And we have this bonding because we have these big lone pairs of electrons here. So the negative charge is there. We have the attraction to the plus 3. What is it called when a positive and negative attract? It's a fancy word. Electromagnetic is for magnet. It's close. It starts with electron. Electrostatic. So there is this electrostatic attraction here that's holding this whole thing together. It's strong enough when it's plus 3 that it starts tugging on those electrons enough that it weakens this bond. And so those electrons go away and stay here. And so that thing, this whole thing, is plus 3, as it is in there, so plus 3. But then this whole thing, when this is left, when a hydrogen goes away, what happens to the charge? It goes with it. So this is, these are all still attracted, but this is technically now -1. The hydrogen left. You still have all of these attractions. But this entire thing, I'm taking in my arrows, my apologies, because I'm trying to squish this in, is now plus 2 plus H plus.
Why does only one of the hydrogens get separated?
Once we separate one of the hydrogen, what charge is left? Overall.
Plus 2.
It's just not strong enough anymore.
But does that affect, like, because it's on the whole other side of the other H2Os, for example?
It can still hang on to all of those, but this negative charge now reduces sort of like the overall charge. This is now repulsive to all of those. And so it's just not enough to cause another one to pop off. Now this is in diagram format. You can find these on your table, but they tend to be written like you have it down below. So if we were to rewrite this, we would write it like this. CrH2O6 3 plus H2O goes to CrH2O5, OH2 plus H3O plus, because we're doing it in the hydrolysis format. On your table, how many plus 3 metals can you, well, I'll wait till you're done. Andrew, why is your laptop out?
What?
Why is your laptop out? How many times have I told someone in class to do that?
But I wasn't like doing anything. It was just
I don't know. You might not have been doing anything, but when people bring it out, I'm assuming that they're doing what I would do.
what would you do?
I'd be watching a little video, or taking notes, or writing an email, or
Taking notes is good.
no, not for this class. For the thing that I'm actually actively working on, whatever my current project is. Right now, it'd be Tommy Douglas. Tommy Douglas. What do you learn in Canadian social studies nowadays? Have you heard the name Tommy Douglas in any Canadian social studies course?
We don't have any social studies. We learn about indigenous people.
I mean, that's not bad, but Tommy Douglas is the person who passed legislation in Saskatchewan and is largely credited with founding the entire socialized healthcare system in Canada. It was so controversial at the time, doctors swore they would never treat him or his family. If he walked in a hospital, they would let him and his children die because they didn't want the government to have anything to do with healthcare. They wanted to be able to charge patients directly. He passed legislation that said that his province would pay for half of all healthcare. Very quickly after that, there was universal healthcare across Canada within like 6 years. So he's the person that everybody thanks for Canadian healthcare. and a minority government. Okay, finish off the last two. Just write them in, copy them from above, what they should look like. I'll come around and have a look at what you've been writing. There are only 3 on your table. These are the 3, but any +3 metal that can dissolve in water can do this. There might be some absolutely massive ones that don't. I'd be curious about tungsten because it is so big. Would the charge be diffuse enough? But I think it probably would. But the ones on your table are the ones that you're expected to be able to find because they're on your table. They are not written as a +3 metal. They're written like this because this is how they look in solution. So you're not going to look down your table and find it as Fe +3. You're going to find it as hexaqua aluminum or hexaquachromium or hexaaqua iron. Yeah.
How is this one molecule if there's no actual like bonds with this here?
Those bonds are strong enough that they're considered a permanent addition to the molecule. So if we hold, now if we dry it, the water goes away, but in the solution itself, there are always 6 with it. So it's considered permanent enough that we can say that there are 6 of them there. Just like when you remember hydrated compounds. If you dry, like you've got calcium sulfate, hexahydrate from grade 11. So hydrates in nomenclature.
Yeah.
And that's even dry, those ones still have water. These would only in solution, but they're considered permanent enough that we add them to
But last year we didn't do it like as a molecule, we did it like this.
Yeah, we did. Because that's them as a dry solid. Like dry is in that you can hold it in your hand and it doesn't feel wet. It's attached to it as part of the crystal. So it's a different type of hydrated compound. So we even named it differently. We call them hydrates. These are aquas. They hold the water, but only while in water.
Okay.
Yeah. So we changed even the naming system. We don't expect you to be able to name different ones, although you could look at the pattern on there and probably still could.
Wait,
Finished, you forgot the plus H2O, other than that, you're good.
But what if I,
Right here.
okay,
That's all.
what if I accidentally do this in the test, like,
What if you accidentally did what?
like if something asks me to write this and then I do this, or actually it will be like this, right? 6H.
Oh, I probably would be fine. Because, where's your data table?
Here. I have it.
No, I just also remember Josh doesn't have a data table. You're just gaming. It's so depressing when I walk over and you're just gaming. I trusted you. I trusted you, man.
You just let him down to
Yeah.
well, lucky I got Francis game now.
Local? What about 4? You can always do it because you can just look it up. They give you all 3 that you have to know. So that's the only reason. I was like, but you could have looked it up. Yeah.
I never know when to look something up.
Always look. Always double check. You have
Even
the
if I
table
have 5
for
minutes left
Yes.
in the test.
When have I ever like actively kicked you out at the end of class after a test?
Never, but I kind of don't go well.
That would be it. You forgot the same thing, Nicholas. What? No.
Some of them.
As I say to the other students, you get to me now to get at the end of class. If
Class done?
If you don't, then I give it to your house nerd and he takes it for a week.
Snoop York is out
What you not doing?
Just sit here.
Yeah, maybe help others or just absorb. Yeah.
So,
Well, I don't like that.
Yeah, perfect.
What's up?
Noof is
So up there, if I scrolled up, I'm gonna scroll up. So when we diagram it,
Why do you have like?
I know, bro.
You just went outside.
Andrew,
But what is that for?
Andrew.
Yeah.
So what? When we had this is the same as that, right?
Yeah.
Okay, and then that was so attractive. It was pulling on all these electrons, so that hydrogen left. Okay, and then you get this where there's only an OH left. That OH is that OH. Okay, but the other 5 waters are still there.
Yeah.
So because that hydrogen left, we now have the H3O plus, or here when I didn't do it with water, H plus. Those two, they're equivalent from before. So this is just the formula way of writing this structure. We still have 5 H2Os, 5 H2Os. The old H2O where the hydrogen popped off we can't include it in there anymore because it has a different formula. It's OH minus. So we put it there. The overall charge, +3 minus 1 plus 2. Did that answer your question?
Yeah. Yeah.
Sometimes you say yes, and I don't feel confident. I feel like sometimes you're just trying to.
Well, you're saying like
Good
the
stuff.
H2O from the Cr plus 3, like on the left side, moved over to the
Yeah, this is the same compound after the hydrogen has come off.
Yeah.
Yeah.
And after there's still an OH remaining, so that's why it's.
Yeah. Okay. While I come around and take a look at these, predict whether these salts will be acidic, basic, or neutral, and if they have a hydrolysis, predict what it will be, if any. So, eliminate the spectator ions, write out the hydrolysis, predict if it will be acidic, basic, or neutral. I didn't see yours. Did you write the things? Did you write the things? Oh, yep, perfect. Excellent. Did you write the things? Yep. I don't think I saw Etienne's. What laptop? Oh, don't do Yep, got it. Got it. And you're just finishing off that one?
Yeah.
Okay. And maybe we should do these at the board.
No,
Right.
please.
There's not enough people for that. You want the iPad?
Yeah.
Alright, well then I can't take any more notes.
You aren't taking notes.
I already did. Trust. You said.
No, I came over, I said my trust was broken. I went away.
So I thought we were
Came
heartbroken.
back.
At the end
No,
of the day,
no,
at the end of
no,
the day,
iPad.
You all make it back.
Don't worry.
I'm going with them.
I'll keep playing the game.
Alright, hold up. That's
What is
that
it?
balloon right there.
There we go.
You can use Apple Pencil.
No cards selected. I have no idea how to play this. Putting out that. Putting out that.
It's a
Putting out that. Not enough elixirs. It's just telling me not enough elixirs. I got level 9.
Not Roy.
He's gonna lose the trophy.
Bro, I was already winning hell.
Oh, I got. Oh, stuff just came up.
Hold on, I'll keep you on my phone account.
Oh, threw a Valkyrie in there. Oh, she's getting hammered. That was not good.
Let me watch.
You have 22 seconds left.
Are you waiting?
Oh, I got another Valkyrie. I'm gonna put her on the side now. There, put her behind this guy.
How many towers do you leave open? Hold up. Bro, you're low-key. Oh, he's winning still.
No, yeah, I'm doing
You
okay.
took another tower. You just won the game.
Did I?
Yeah.
Nice.
And Roof hasn't played
Bro,
the
you
game.
play so much.
Uh-oh.
Unintentionally wins.
I'm out. Oh, match over.
We won, yeah.
We won.
Unintentionally wins Clash.
Excellent. Okay.
That's crazy. Bro, play the most strategic RJ ever pulled the pack across the board. Yeah.
Are you now in that particular version? Are you playing against real people or is it against
Yeah.
bots?
Real people.
Nice, I got 4,000 points. Wait, that's in classic? It's in classic over.
Lunch today.
2 people.
I've signed it.
There we go. Okay, find your person, start doing 1, 2, 3 on the board. You had time to look at them.
Wait, which one's
Yo, let's go. I know I was.
on my way?
Josh, get your ass away. What are we doing?
Those 3 problems on the board. They're the last 3 problems of the sheet.
Well, at least it's stupid enough to think reverb isn't a real word.
No, it's not that.
Nice.
That's the thing, I never PCL I know it's.
Oh, you said to get back in other class or next week?
And the class.
No, that's the thing, I don't know where it is.
Does it say Sam's on Northwest?
I haven't put the official attendance in, I just did it on my app.
Does it say he's not here? Like,
No, I haven't looked yet.
Yeah, see that marker? Yo, don't give it to him, give it to me.
Because I just did it on my app.
Mine now.
Oh, this is someone else's fault.
guys, will it combine? I don't remember.
You know, what I think like a nice.
Bro, that's crazy.
Because there's no such thing as NHPCL.
CL stuff.
Is it plus H2O?
I guess you could just.
I literally showed you using the photo.
Schedule.
You wouldn't include
Oh yeah, that one.
Yeah.
Yep. Josh, you were concerned, he's in the health center.
I don't know how I did, but I thought I did good.
Tim, Lavina, dude. Ella.
F minus is a weak base, right?
Bro, this guy is still doing 2A.
You have a.
Sonia, Andrew, Nathan, Victoria, police golf. Katie.
No.
Meyer,
No.
Lev, Matt, Sal, she's good.
I know, it's so crazy.
So this would.
Oh, you need to say whether it's basic, neutral, or
correct.
acidic.
They're all looking good. You gotta see if they're acidic, basic, or neutral, and your last one needs some work.
What do you mean?
Your last one isn't quite right.
Elaborate.
Pardon?
Elaborate, please.
Oh, I think it's the library.
I said elaborate.
Yeah, some of it's right.
Like, what's right?
The spectator ions, you can get rid of them if they're plus 1 or plus 2.
Metals plus 1 or plus 2 are always pretty much spectator ions. And the negative ones are always conjugate of the strong acids, chlorine, nitrate, all those, except for hydrogen sulfates. You get rid of those, cross them out, and then react with whatever's left. Yeah.
That's why CL's
Yeah.
Where does the CL go?
Is it a spectator ion?
Yeah.
Then you get rid of it.
But like, what if we're not doing a net?
You would just put it wherever it belongs, so you'd end up with NH3 plus HCl.
HCl?
H3O plus Cl, which is HCl, which is a strong acid. I know you can't create that. You're just creating an H plus.
But like,
Cl doesn't get hard.
yeah, but like, if we.
Don't erase the back of that.
And it's asking us whether it's acidic, basic,
Like this?
And that's 100% soluble too. Like if you're gonna do it, you can separate them that one. But in writing, it's
Yeah.
yeah, we go there exactly as you have it. How we doing?
We're done.
NH9 nice on the last one. Not neutral though.
Yeah, it is.
No, so.
Is it
Who
like,
did that one? Who did you do that one with? Pardon? Katie? That one? And first of all, it charges H4 plus.
Is it?
That's okay.
Where is it?
However, not neutral.
What?
Oh, yeah. Those are right.
It doesn't matter which way you do it.
Yeah, no, fair, but not neutral.
It should be a
We have
base.
two reactions. Are they both identical?
That's the H.
No. So which one's stronger?
This one,
So
How do you know?
base.
because it's
So it's
stronger
not
acid.
spectator. And
Well,
H4
NO2 is
not
an acid, it's a
spectator,
base.
so They're both
It's
weak.
stronger, like
This is a weak acid and weak base, right?
How do you know?
Because NO2 is lower on the
Excellent, prove it.
2 was here, H4.
Pardon?
Very strong at the table.
You can get the Ka for one, what could you get for the other ones?
Okay.
There you go. Josh, go do that in yours too.
No, we did it
So
right there.
what?
There's no K in KB. But.
Alright, I'll do it.
wait, what do you want us to do?
I want you to prove whether it be acidic or basic or neutral for the last one.
So
But
it's Hazel and four. Alright.
Bam, this is an acid, this is a base, what do you need?
Wait, Nuke, could
Yeah?
3D both?
yeah, yeah,
So, you should have said we're exactly half right. We did half right.
yeah, you did.
No, you said some is right. We should have
I could, but I didn't.
I was like, oh yeah.
Nope.
And then this would be. What did we do for it?
It does both. One of them is gonna be stronger.
Meaning.
Let's say both of them happen. The OH cancel.
Can you comment down like those caveman words?
Caveman words, I like those.
I'm stupid.
Pure base.
Yeah. Yeah.
Okay. Assuming both are.
Okay. Yeah.
These two.
You
Fully
lost.
counteract. Fully counteract. Only these two, right? Only these two. This is a strong base. This is not a strong base.
Okay.
Or a strong acid.
Yeah.
So this is what strong base.
Okay.
That would be correct.
Okay. Fine.
I've been in this class less than you.
I know. I'm slow.
Everyone knows. You're 7 people.
Do we need to calculate the KV?
For the last one, yeah. Because otherwise, how do you know what it is?
Because math.
Because
Math is the best way to prove things. I'd have a huge argument last night with Zach Young.
You don't argue with Zach Young because
He
thinks
believes all math is completely useless. He doesn't need to learn anything in grade 9. And then he said he's fundamentally he can't learn it. And then we found out he doesn't know his timetable. So our new thing is he has to do timetables every night. We're gonna get Zach Young to learn math.
Yeah.
Yeah.
I like
I was about to one year, so like that's what
You don't need to. You can just see.
No, you told us that we need to. We need to calculate.
No, but you can see that this one is a stronger base and this one is an
But when
acid.
Neufeld says, please calculate, you need to say calculate.
You gotta calculate. How do you know?
Because it's higher on the table.
Well, but the other one's lower on the table.
Yeah.
Where it's strong, it's weak. Like their trends are weak and strong versus high and low. So we've got NH4 plus, which is where? There. Quite low on the acid side. And we have NO2 minus, which is quite high and weak. It would be really difficult to tell. You probably need numbers for that one. It's times 10 to the minus 14. That's times 10 to the minus 10. To calculate the KB, you're gonna get about times 10 to the minus 10 because that's a minus 4. So probably gotta get the number. Probably do. Remember, I'm just helping you.
NH4
That's 5.6.
They're all 2 sig figs, that's 2.2.
That's 5.6.
Do you have that?
When do you see this already?
We were doing it,
What is the? I think now I told every group. What is the Ka for NH4 plus?
That
What is? Say what it is.
5.6 times 10 to the negative 10.
This?
And then the KB.
4.6 times 10 to the negative 4.
Did you calculate that?
That's the KB.
Damn,
That's
guys,
the,
you
no, you don't need to calculate that.
No, that goes on the ballot.
Is this an? Do you need a KB or Ka for this? You have a,
You need a KA, but like, I use the KB to solve for the KA.
you use the Ka to solve for the KB. It's a table of Kas.
I thought you went one,
And now we just have
1.0 times 10 to the negative 4.
Yeah, Kw over Ka.
Divided by 4.6.
Excellent. Yes.
We have to, we have
So that would be
how much of this and how much of this.
1.0 times 10 to the minus 14 over, what was that number you said?
4.6 times 10 to the
Okay,
negative
no, that's the bottom. I did the bottom end of the top.
Perfect. And what'd you get?
Wait, dude, but isn't something
2.2.
KB for
One second. Say it again.
2.2 times 10 to the, I don't know about my whole
11, bro. 11.
I think it's 11.
Perfect. Okay. Gleb,
Yeah.
NO2
What did you do?
is on this side.
So what did that be?
This, no, this is the Ka for its conjugate acid. This is a table of Kas. So you have to go there. This base side, I have to go 1.0 times 10 to the minus 14, divide by that, and get the Kb for the base. Okay. Go all the way back. So will this final solution be acidic or basic?
Acidic.
By a narrow margin acidic, we have 10 to the minus 10 and 10 to the minus 11, so it will barely be acidic. It's probably going to have a pH of like 6.8 or something. Like it's going to be barely acidic. So if you guess neutral, if I was, we used to teach something like this to grade 11s a long time ago, and we wouldn't make them do Kas or Kbs, we just use the table, and then we get to say neutral, because it kind of is. But if we have access to the numbers, we can say, yeah, it'll be a little bit acidic. This is how you can make buffers. If you take something and you add both conjugates in there, then it will have a pH, but it will also have something to react with, and so it will keep it at about that pH until you exhaust it.
So wait, for the last part, you were just trying to get us to figure out which was the stronger acid, and
Which was the stronger reaction? So we have an acidic reaction, Ka,
yeah.
but then we had a basic reaction, so you had to calculate the Kb. Remember our Kw is equal to Ka times Kb? This is 1.0 times 10 to the minus 14. And you can look up the Ka off the table, and then you just calculate the Kb. And that's what it is. That's the calculation. What time is it? 11:59. Are we done at 12 or 12:05? 12. 11. No, we're not. Hold it. Are we? What's
It already
today?
is 12.
It is. Oh, there we go. Okay. So today is Wednesday. I won't see you on Friday.
See you next week, Bob.
But because we don't have class on Friday, if you come check in between the class, you might get a treat.
Like,
And tell me how much you missed not having class. Pardon?
An extra like 50% on your grade treat? Or like what kind
No, not that kind of.
Extra 50.
That's not a treat. That's like teacher fraud.
No, it's not.
It is.
It's only the
That's just giving, I mean, if I'm gonna do that, I need to be compensated in a way that when I get fired, I can still live a comfortable life that I've been accustomed to. It's a lot cheaper than you probably thought. Reminder, right away, $7 million broad, guaranteed C minus.
Thank you.
C minus
Yeah.
for 7 mil?
Yeah.
What's an A plus?
Guaranteed.
As
if you have a
to
zero.
C, C plus, B, minus B, B plus,
I'll let you play another
A
game on
minus,
Clash
A
account.
plus, at $7,070. Once you meet the minimum, all the other tiers are pretty cheap.
Thank you.
You're welcome. I did have someone once mention that they couldn't do 7 million, but they could give me a lifetime supply of food.